which topic we had covered in the last class, as I lost the PDF notes.
Yes, sir, we were here earlier at the Stephen reaction. Because I had to leave like halfway through, so I stopped. I was there to Stephen reaction.
This part we had already covered, right? This
Yes,
from
sir.
nitriles and amines, right?
Yes, sir, we did this. Yeah.
We did this. And also, I think we had covered the preparation of aldehyde from this hydrocarbon. That is basically the first one was use of chromyl chloride, right?
Yes, sir. This one, yeah, we did. Yeah.
And also this basically this is known as Etard reaction that we covered. And I think also we were done with use of chromic oxide, CrO3, right?
Yes, sir.
And the next one, Gatterman, we also did, right?
Yeah, Gatterman, course, yeah.
Okay. So today we are going to do the preparation of ketone. We covered the preparation of aldehyde. Now it's topic. It's time to start the preparation of ketone. Preparation of ketones. Ahmad, is this your first class?
Yes, I think so. Your class, yes.
Okay, no problem. So you have studied this chapter before, right?
Yes.
Okay. So let's start preparation of ketones, and we are going to prepare this ketone from acyl chlorides. Acyl chloride is a basically functional group, and the general formula for acyl chloride is RC double bond OX. This is acyl chloride. This R is alkyl group and C double bond OX. This is acyl chloride. And if you want to go for aldehyde, this will be the same, but here it is H. So this is aldehyde. So please try to recognize which functional group is present in any compound. So we are going to prepare the ketone and we are going to prepare it from acyl chloride. So basically first we need to treat. I'm going to write treatment of acyl chloride with dialkyl cadmium. Dialkyl, that means the alkyl part is twice. R2CD, we can say this is dialkyl cadmium. Prepared by reaction of cadmium chloride, with Grignard reagent. So it's very easy. First, you are going to react this cadmium chloride, which is CdCl2, with Grignard reagent. That means basically RMGX. Then we will get dialkyl cadmium, and this dialkyl cadmium will be reacting with acyl chloride to give ketone. Is that clear? So first you are going to write this sentence and then I'm going to show the reaction and explain the reaction again. Let me know when you are done with this. Everyone done with this?
Almost done, sir.
Okay.
Done, sir.
Okay. Alan, Mehraj,
Yes, sir.
no. Now I am going to show you the reaction. It's very easy to understand. First, you are going to react this RMGX. That means basically the Grignard reagent with cadmium chloride, CdCl. We are going to take 2 mole of this in order to balance the reaction. Then the product will be, you can see, the product will be R2CD. R2CD, I'll explain the mechanism also. And then here it will be Mg, and then X was there. So MgX, and it is C. So how the product formation took place, it's very easy to understand. As you know that this CD, cadmium, is a metal, which means it is electropositive, and Cl, which means it is electronegative. So negative charge will be here and positive charge will be here. In the same way, you are going to do for magnesium and carbon. This R is alkyl group, that means carbon containing group. So magnesium is metal, so it is electropositive. So I'm going to write positive here and negative here. Now what you need to do, you know the nature, positive will be attracted by negative and negative will be attracted by positive. In this way, Mg, and you can see this MgX is there, and Mg will be forming a bond with chlorine, so it will be MgHCl, and you can balance it by multiplying it by 2. And you can see CD, cadmium, has basically +2 oxidation state. One will be satisfied with one alkyl group, so that's why I wrote R2CD, because one R will have -1 and CD alone has +2 charge. So in order to satisfy cadmium, 2 alkyl group will come and combine with this to form R2CD, which is known as your dialkyl cadmium. Dialkyl cadmium. This is your dialkyl cadmium. Is this clear to everyone? This is your byproduct for this step of reaction. Now, this dialkyl cadmium will be reacting with acyl chloride. Will be reacting with acyl chloride. You can see this is R2CD, and what you will get an a ketone, RC double bond OR, and CdCl2 again will be produced as a byproduct. Now you can see how the reaction took place. It's very easy to understand. Again, the same concept. This will have negative charge, this will have positive charge, this will have negative charge, this will have positive charge. So positive, negative, this negative will go to this carbon. So you can see R dash C, and C will be forming a bond with R. So it will be like this, and this Cl will come with this. So in order to balance it, you are going to multiply it by 2. You are going to multiply it by 2, and now the product is formed. Now again you can do the reaction. How? This CdCl2 will be again reacting with Grignard reagent and again forming the dialkyl cadmium, and this dialkyl cadmium will be reacting with acyl chloride to give you ketone and again CdCl2. Is that clear? So this CdCl2 is treated as byproduct. Your main product is this. That we just started the preparation of ketone from acyl chloride.
Yes.
So please do write it, everyone, and let me know when you are done with this. Everyone done with this?
Yes.
Okay, now I am going to give you a question. This is your CH3 MGBR, or I'm going to take, yeah, MGBR, reacting with CDCl2. Then tell me the product. What will be the product that you will get? The main product for this step is R2CD. So just let me know the name of the product. You can balance it by your own. It will be 2 here.
CH3CD plus MgBrCl.
CH3
CD plus MgBrCl.
Oh, got it. Got it. You told me the byproduct is MgBrCl, right?
Yes, sir.
And this is your CH3CD.
Yes, sir.
Okay, if I'm going to write AlCl, is there any compound that exists as AlCl? We write AlCl3, right? Or just take another example which is more easy. If I'm going to tell you, can you tell me a compound which formed by the combination of Mg plus Cl? What will be the formula of this compound?
MgCl2.
MgCl. Why it is so? As you know that this chlorine, this magnesium will have +2, and this chlorine has only one negative. So if it will combine, it will be forming like Mg plus and Cl, right? Because this one negative charge will be neutralizing the charge on magnesium +1 only, but then +1 will be left. Then again one chlorine minus will come and neutralize it, and then form MgCl2. Are you getting my point?
Yes, sir.
So basically this cadmium is in +2 oxidation state. This cadmium is in +2 oxidation state. That's why there will be CH3 hold twice. That's why there also R2CD, dialkyl cadmium. And here its name will be dimethyl cadmium. Is that clear, everyone? Zed, Ahmad, Alan. Then again this CH3 hold twice. Basically, I'm going to react this with, if I'm going to react this with CH3, CH2, C double bond O, Cl plus CH3 hold twice, CD. Can you name the major product or the main product? Can you write the IUPAC name of the major product? Main product.
So trimethyl cadmium.
What you just said, Alan?
Trimethyl cadmium.
Dimethyl Cadmium.
Try, yeah.
No. See, Alan, when cadmium chloride will be reacting with Grignard reagent, then you will get dialkyl cadmium. But here you can see this is cadmium, it will have positive sign, this will have negative sign. Since carbon is non-metal, it is electronegative. Cadmium is a metal which is electropositive. Then again, chlorine is more reactive. Carbon and chlorine both are non-metal, but chlorine is more electronegative, so it will have delta negative and this will have delta positive. So this will come here. It will combine with carbon and this will be going with this. So you will get CH3, CH2, C double bond O, and this CH3 will be combining with this, and then the byproduct is CdCl2. So your product name is 1, 2, 3, 4. So it is butane 2 on. This was the first step, and this was the second step to prepare the ketone. Please do let me know if you have any doubt in this.
Can I just explain that example again?
Yeah, Ahmad, can you repeat it again?
The second example, sir, which you just showed, CH3, CH2. Can you just explain that again?
Yeah. Are you talking about this, right?
Yes, sir.
See, Ahmad, the second step of the question, it's same as this. As you can see that C double bond or Cl. So between carbon and chlorine, can I put negative charge on chlorine because it is more electronegative than carbon?
Okay.
So
Okay.
chlorine will have negative charge than carbon. To the chlorine, whichever atom is connected will have positive charge. Now come to this CH3 and CD. It is metal, so positive, and carbon, so negative. And just add negative to positive. This is the nature. Negative will be attracted by positive, or positive will be attracted by negative.
Yes.
So it's very simple.
Okay.
So please do write it. I am going to give you another question, another chance.
Thanks.
Please do let me know the main product. A is the main product of the reaction. And whatever is the A, you are going to react with acyl chloride, then you will get C plus D. C is the main product. Please do let me know A, B, C, D. B and D are basically byproducts.
So A is dimethyl cadmium.
Like this, Alan, right?
Yes, sir. And C would be propane 2 on.
So let me just check. It will have positive charge. This will have negative charge. This will have positive charge. This will have negative charge. So this negative will be going to this. So it's very good. CH3 is there. Carbon methyl group will be connected with this, and then CdCl, right? So this is your C. This is your D. This is your A. What about B? B is very simple. what will be your B? It's very
Yes, sir.
simple.
B is
Mg.
yes, sir. B is MgBrCl.
MGBRCL, yes.
MgClBr, right?
Yes.
Ahmad and Jad, do let me know if you are done with this.
Done, sir.
Done, sir.
Okay. So moving to the next type of preparation. First, we have completed from acyl chloride. The next is basically from nitriles. From nitriles. Nitriles is basically is a functional group that is RC triple bond N. This is your nitrile CN. So how we are gonna prepare it? So basically we are going to treat or react nitriles with Grignard reagent followed by hydrolysis. So nitriles will be treated with Grignard reagent followed by hydrolysis. Followed by hydrolysis. So it's just like I'm going to take an example, then you will get it. This is your nitrile CH3CH2 C triple bond N. And if it is going to react with C6H5, that is R, MgBr. This is your Grignard reagent. And this reaction will be in the presence of ether because they are very reactive. That's why they are in the presence of ether. So what will happen? It's very easy to understand. There is CH3, there is CH2, and then this C, and then there will be double bond N MgBr, and another bond, this will be C6H5, and this will be followed by hydrolysis, that is H3O positive. Then you will get C double bond O. Again, this is your C2H5, that means CH3CH2. I'm going to write it as C2H5 and then C6H5. So please do write it, then I will explain. First you are going to write it and then I will explain.
Done.
Done everyone? Ahmad, Alan?
Yes,
sir.
sir. Done.
Okay. So I'm going to explain the reaction so that you will be able to solve this type of question. So I'm going to write it again. See, there is CH3, there is CH2, and then there will be C triple bond N. As you know that in this compound, every element is satisfied with their bonds. That means basically carbon is making 4 bonds. So it is basically a stable, and if you want to add something new, you need to break the old bond. Is that clear? If carbon is making 4 bonds and if you want to add chlorine in that, what you need to do? You need to break one of the old bond to add chlorine. Carbon cannot make 5 bonds. Is that clear to everyone? Is that clear to everyone?
Yes, sir.
So just do reply, please. This is just I'm going to again explain. This is your CH4, and if you want to add chlorine to this will be wrong if you are going to do this. Carbon cannot have 5 bonds. So what will happen? One old bond will be broken and then chlorine will be added. This is the correct step. Yes or no?
Yes, sir.
Now see what I'm going to do. It's very simple. As you know that, can anyone tell me carbon and between carbon and nitrogen, which is more electronegative? Carbon and nitrogen, which is more electronegative? Anyone?
Is it carbon, sir?
No. See, carbon is here, then nitrogen. Whenever we are going to move from left to right in a period, electronegativity increases. And also you need to remember that this is FON, phone. This is the first most electronegative element, then second most, and then the third most electronegative element. So nitrogen is more electronegative, so it will have negative charge, and this will have positive charge. Now, can you tell me magnesium and carbon? This will have positive charge, and this will have negative charge. Now, what will happen? This positive will come to the. Oh, wait a minute, please. As you can see, this negative will come to this positive. So if you are going to write triple bond N and then CH2 and then CH3, and then if you are going to add this C6H5, it will be wrong because carbon now making 5 bonds. So what we need to do, it's very simple. Just break one of the old bond between carbon and nitrogen. Now it will be double bond. Now it will be double bond between carbon and nitrogen, and then C6H5 can adjust with carbon. Now you can see this is positive, this is negative. So this positive will go to nitrogen and it will form MgBr. Is that clear?
Yes, sir.
And now if you are going to do the reaction H3O positive hydrolysis of this all will be broken and there will be oxygen that will come from water, and you can see this is your ketonic will form, and the rest is byproduct. So please do write it. If you want, let me know. Then I will give you a question on this. Can I change the slide?
Yes, sir.
Okay. Now, if I'm going to give you a question like this, CH3 C triple bond N will be treated with C6H5 MgBr. Then you will get a product A, which on hydrolysis will give product B. Just name the product, write the product.
Sir, A is CH3 C double bond O N. Sorry, C double bond N MgBr and single bond C6H5.
Okay, A is basically your CH3C double bond N MgBr, right? And
Yes, sir.
here it is C6H5.
C6H5.
And then you are going to do hydrolysis of this and you will get CH3C double bond O C6H5.
So can you explain this hydrolysis thing once again?
See, when you are going to hydrolysis, there will be two part, H plus and OH minus. Okay, so basically this bond will be broken and oxygen that is present here will be going to attached with this carbon. So you can understand like this. This is your NMGBr. So from this OH minus hydroxide ion, oxygen will be going to satisfy the carbon bonds. Since this bond will be broken, you can see this is double bond. If it is broken, so oxygen will be go and satisfy this carbon, and in this way ketone will be formed. In the same way that if we are going to break one of the bond and forming double bond between this, in that way. Everyone done with this?
Yes, sir.
Okay, I'm going to give you another question on this. So if I'm going to give you CH3, CH2, CN, that will be treating with, wait a minute. I will explain the mechanisms that it's not that much long. First, you are going to write it and then I will explain the mechanism. Are you done with this?
So okay, explain.
Okay. See, what will be the product here? You can see this will be CH3, CH2, and then C double bond N, MgBr, right?
Yes.
And here it will be CH3, CH2. And again, if you are going to do hydrolysis of this, you will be getting CH3, CH2, C double bond O, CH3, CH2, right? CH2, CH3. Oh, wait a minute. It's CH2, CH3. This is the answer you got. Pentane 2 on Zad, Ahmad, Alan.
Yes.
Okay. So Zad, you asked how this hydrolysis take place. So I'm going to take an example, basically the mechanism. Should I change the slide?
2 minutes.
So 1 minute.
Okay.
Yes, sir.
Okay. So just suppose we have this, before hydrolysis, we have this C double bond N, and this is your CH3, and this is your pH. That means basically C6H5. And you also know that this is your MgBr, and you also know that nitrogen will have lone pair. So there will be H3O positive, that means H plus. So this H plus you can see is electrophile. This H plus is electrophile, and this nitrogen is nucleophile, that means electron rich species. So it will attack this part. So I'm going to remove this part and I'm going to write N H will be there, then double bond, and then we can write also, let's say here it is hydrogen only, not MgBr. We can treat it or not as per our convenience. If you want to put MgBr, that is well and good, and if you want to put H is just suppose H is equal to MgBr. So it will be easy to write. Now you can see that carbon is here, CH3 is here, and pH is here. And since nitrogen donated one electron to hydrogen and make a bond with hydrogen, nitrogen will have positive charge. Now see what will happen. Positive charge on more electronegative element is less stable. Positive charge on more electronegative is less stable. So in order to satisfy itself, what will nitrogen do? It will take electron from carbon. It will take electron from carbon. So there will be deficiency of electron on carbon. So that's why this H2O will come into play and it will attack this carbon to satisfy this carbon. So you can see now carbon will have 3 bond, this CH3, then pH, then single bond NH2, and then this part OH2. Are you getting my point?
So can you just explain it again? I didn't get it.
What you just said?
Can you just explain it again? I didn't understand.
See, wherever is the problem, just tell me. This is H plus, which means this is electron deficient,
Okay, correct.
and this nitrogen has a lone pair, that means it is electron rich, that means nucleophile, and this is your electrophile. So it will attack hydrogen. Since it has given one of electron to hydrogen, it will have positive charge.
Okay.
And it bonded with hydrogen, now it becomes H2. So the rest part does not change. CH3 as it is, pH as it is, C double bond N, only positive charge comes, and there is one more hydrogen because nitrogen bonded with hydrogen, and there will be positive charge because it donated one of its electron. Is that clear?
Yes, sir.
Now, on more electronegative element, positive charge very less stable. Positive charge very less stable. Are you getting my point? Nitrogen is third most electronegative element in the periodic table, so it is very less stable when it has positive charge. So in order to stabilize itself, nitrogen will take electron from this carbon.
Okay.
So when nitrogen will take one of its electron from carbon, so now it will be singly bonded. See, this was like this, and it will take one of its electron from carbon, so it will be like this.
Okay,
So
okay.
now nitrogen has deficiency of carbon, sorry, electron. So that time we are doing hydrolysis. So water will be present and oxygen has lone pair. So oxygen will donate one electron and make a bond with carbon. And now oxygen will have positive charge. Is that clear?
Yes, now
Yes,
clear.
Now see, it's very easy to understand. As I told you, on more electronegative element, positive charge is very unstable. Oxygen is the second most electronegative element. So what will happen here? It's very easy to understand. What will oxygen do? Oxygen will take electron from hydrogen. Oxygen will take electron from hydrogen and it will satisfy itself. So it will be CH3, then NH2 will be there, and then pH will be there, and now it's OH. Is that clear?
Yes, sir, clear.
Now see, again H plus will come into play. This is the mechanism that I am explaining. H plus will come into play, and since again this nitrogen has lone pair, so this will be attacking there. And again you can see this is CH3, this is pH, this is OH, and this is basically your NH3 positive. NH3 positive. Again, nitrogen has positive charge, so it is very unstable. So what will do? What will nitrogen do? Again, nitrogen will take electron from carbon. Nitrogen will take hydrogen electron from carbon, and it will be released. It will go out. And in order to satisfy carbon of electron of carbon, oxygen will be broken its bond with hydrogen and it will use with carbon. So this is your ketone. What happened here? Again, this H plus will be bonding with NH2. Now it is NH3 positive. Positive charge on nitrogen very less stable. So in order to satisfy itself, nitrogen will take electron from carbon and it will be released. It will be evolved in the form of NH3. Since nitrogen take an electron from carbon, carbon will have positive charge, and to satisfy the valency of carbon, oxygen will take electron from hydrogen and it will give to carbon and make double bond. So this is the mechanism behind this. And the mechanism of this will not be asked. Zed, is that clear?
yes, sir.
Ahmad, Alan. So I am sliding it up. So please do write it step by step.
So for exam point of view, should we write the statement also which you have written here? On more one more EN element statement we have to write that, or does the steps will be okay?
Actually, this mechanism is not in your syllabus. Zad asked, that's why I just explained.
Oh, then
Okay.
okay.
Please write it. Knowledge. Let me know when you are done with this. Done, everyone?
Last almost.
Okay. Please do it and let me know.
Done, sir.
So you are also done with this. Alan, you are also done with this.
Yes, sir.
Okay. So now the next preparation and the last preparation of ketone. That is basically the third preparation from benzene or substituted benzene. Do you know what does this substituted benzene means? Any one of you, what is substituted benzene? One is a normal benzene, that is basically this is your normal benzene. And what is substituted benzene? There will be substituent like CH3 or NO2 or Cl. Anything will be attached with this benzene, that will be known as substituted benzene. So how we are going to do the reaction, and this reaction is also known as Friedel-Crafts. You have studied this in first chapter of organic chemistry, haloalkane and haloarenes. Then alcohol, then you have studied in alcohol chapters. You have also studied this Friedel-Crafts alkylation as well as acylation in class 11. This acylation is basically your preparation of ketone. So Friedel-Crafts acylation reacts. So I'm going to write a point about it. So you please do write with me. When either benzene or either substituted benzene is treated with, this is E, treated with acid chloride, basically acyl halide, acid chloride, in the presence of anhydrous aluminum chloride, in the presence of anhydrous aluminum chloride, then ketone is formed. Ketone is formed. Like if I'm going to prepare ketone from this method, there is benzene, there can be benzene or substituted benzene also. This is your benzene, and you are going to react either with AR, that means arranes benzene group, and R, COCl, acyl chloride, in the presence of anhydride AlCl3. Anhydride AlCl3. Then you will get a product. Hydrogen will be removed and this will be connected directly, either AR or R. See what happened. Every carbon in benzene will have one hydrogen. Every carbon in benzene will have one hydrogen. So this hydrogen will be broken. That means basically you can take it like this. This carbon has taken electron from hydrogen, and now it will have positive charge, and this will have negative charge. So they combine with each other and form a byproduct HCl. Now this carbon, basically this carbon in benzene, will have negative charge, and since this carbon has donated electron to chlorine, it will have positive charge. So they combine with each other to form a ketone. Is that clear?
Yes, sir.
Please do write. Do let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. I'm going to give you a question on this. So, if you have this part and you are going to react, substitute. Please do let me know, man, if you have any doubt.
Sir, done.
Very good. What is the product you have got? Let me write the answer. So it will
C
be
double
basically
bond
like
O
this.
connected to 2 benzene plus HCl.
This is the product.
Yes, sir, plus HCl.
This is the byproduct. And if you are going for this, this will be like this, right?
CH3 plus HCl. Yes, sir.
Everyone done with this?
Yes, sir.
Okay. So now I'm going to give you again question. The topic we have covered. Write with me. Write the structures of products of following reactions. Of following reactions. Wait a minute, please. Please do. There are 4 reactions that I need to give you. First, write it and let me know. Then I will write the next.
Sir, done.
Both the reactions are done.
Yes, sir.
Okay, I'm going to give you the third reaction. Everyone done, right?
So almost.
Please do let me know when you are done with this.
Then the third reaction, it is Hg2 plus, right?
Yeah, Hg plus 2.
Sir, done.
Very good. I'm going to write the product Please pull focus. So if you're going to write the product for the first one, it's very easy to write. This will be like this, the benzene, and then it will be C double bond O, and then CH, then CH3, then CH2, and then CH3, right? This will be the answer, and the byproduct is HCl. Ahmad, Alan,
Yes.
okay.
Yes, sir.
Now, if you are going to do the product for the second one, you can see this is C6H5. So the product will be C6H5. So I'm going to just open it. This will be C6H5. And with this C6H5, CH2 is there. So there will be CH2. And then you can see this is CH3 double OL. That means it will directly come to this and it will be like this. And the rest part is CDC. This is the product for the second. Zach, Ahmad, and Alan.
Yes, sir.
Yes.
Okay. I'm going for the third one. See, this reaction you have studied it in class 11th. If you are going to treat propene or basically alkyne with Hg plus 2 in the presence of H2SO4, then you will get an alkene first. Then you will get an alkene, alkenol. Basically, you will get alkenol. This you will get alkene, that means double bond, and then all that means alcohol you will get. Basically, what will happen here? It's very simple. Carbon bond will be broken and then this will form. So you can see if I'm going to write it like this, one of the bond will be broken and then alcohol H2SO4 from H2SO4 OH will be connected with this and hydrogen will be connected with this, and then tautomerism will take place. Tautomerism. And how tautomerism works, it's very simple. It's very simple. You can see this is OH, this is OH. So basically this bond will move to this and this hydrogen will move to this and you will get CH2C double bond CH. Please do write it. Is this correct for all of you?
Yes, sir.
Okay. Now the next is basically CrO2 chromyl chloride. Then you will get a product which is very easy. Directly I can write is that, see, if I'm going to write this, we can write CH3 is here. So I'm going to directly write the product that will be NO2 was here and this CH3 will be oxidized into aldehyde. Preparation of aldehyde from hydrocarbon, in which we had studied the use of chromyl chloride, CrO2Cl. So this is it. Can I change the slide?
No, 1 minute.
Okay, please do write it.
Done.
Okay. Now we are going to discuss about the physical properties of aldehyde and ketones. So you can see first we are going to talk about physical form of some of the compound, like methanol is gas at room temperature. At room temperature, methanol is gas. Second, we can write ethanol is very volatile liquid. Ethanol is volatile liquid. And other aldehydes and ketones are liquid or solid at room temperature. Other are liquid, either liquid or solid at room temperature. There is one important question that has been asked from this physical property, that is arrange the following in increasing or decreasing order of boiling points. Increasing or decreasing order of boiling points. And always remember that this increasing or decreasing order of boiling points directly proportional to basically surface area. Wait a minute. Boiling point directly proportional to molecular weight. Molecular weight. That means if you are going to compare a compound aldehyde with a lower molecular weight with and higher molecular weight, then the higher molecular weight aldehyde will have more boiling point than lower molecular weight of aldehyde. Molecular weight and also directly proportional to surface area. Always remember that. So I'm going to give a question to you, that is basically there is a paragraph in NCERT that is given. This is your butane, to just have an idea. Methoxyethane, propanol, acetone, propanol, that means alcohol. So basically, if you are going to see the boiling point, it will be 273, then 281 Kelvin, then it's 322 Kelvin, then it's 329 Kelvin, and then it's 370 Kelvin. Do you know why alcohol has higher boiling point than all of this? It's because it has hydrogen bonding, which is giving extra stability to that. So if I'm going to give you a question, just compare in your own way. Arrange the following compounds in increasing order of their boiling points, BP, and the compound names are CH3. Can I write the bond line structural formula? If I'm going to write like this, will that be okay for all of you? Will this be okay for all of you?
So,
Yes, sir.
Okay.
so 2 greater than 3 greater than 1 greater than 4.
Very good. What about Ahmad? So basically in this you can see this is alcohol and it will make hydrogen bond. So it will have the, now I'm going to take A, B, C and then D. It will have the highest boiling point. Then this aldehyde will come and then this methoxy group will come. That means ether, and the lowest boiling point is of this alkane. Is that clear, everyone?
Yes, sir.
Now the next question on this type is basically your this CH3 CHO and then CH3 CH2OH and then CH3O CH3 and then CH3 CH2 CH3. Please do this. Everyone done with this? It's also very easy. You can see this is aldehyde with a comparable molecular mass. This is your alcohol, this is your ether, and this is your alkane. So B, then A, then C, then D. Is that clear? Ahmad, Zaid, Alan?
Yes, sir.
Yes, sir.
Okay, so this is it for today. I will see you in the next class and we'll continue the chemical reaction. Okay?
So, so tomorrow I have test on this aldehydes, ketone, and carboxylic acid. So, like, what all topics are important? Unit tests are there.
Okay, from carboxylic acid. Your unit test is based upon carboxylic acid or all
No,
on
no, whole chapter, whole chapter.
all this chapter, whole chapter. So basically, the most important reaction is your aldol and canizaro. Aldol and canizaro reaction is one of the most. How many? How much uh, of a score it is? 20 marks.
No,
50
10,
marks.
10, 10 marks.
Then please be focused on canizaro and this what I just told, aldol. And also there are some points that you need to cover from this NCRT, that is acetaldehyde, not acetaldehyde, acetal, hemiacetal, and there are a lot of name like this. You need to cover that. That will be enough.
Sir, so the preparation is okay, and the physical, what for priority order should be what?
You should revise some new topics, like you should read about aldol, canizaro. Wait a minute. And then there are some terms that are very important from this chapter. That is, there are reaction basically. Cyanohydrine. You will see it in the back exercise. Acetyl. Cover some of these topics, and then it comes 2,4 DNP derivative. These are most important topics. If the whole chapter is coming, oxime, hemiacetal. There are some, I think there will be 10 to 9 topics like this cyanohydrin acetal 2,4 DNP derivative. What is it? Just read about it and the reaction, and then it will be all good. Okay.